Hey everyone, welcome to the last installment of the Arduino and two thermistor data acquisition system series. This is the last video talking about the programming side of things. In video 1, we talked about building the circuit with the two thermistors and the voltage divider and the LEDs. In this video, we're going to talk about the last option, using Arduino to code the microcontroller and MATLAB to visualize the data. So let's start. So we're going to start with the Arduino IDE code. And we're going to start from the code that we wrote in tutorial 2 because it actually does everything we need it to do, and the problem is only that it does too much. So we're going to take out some stuff to have it fit our needs a little bit better. So the first thing I'm going to do is comment out the serial prints of the header lines. And this is just because we're going to tell the computer when it's reading the serial feed to expect a certain format. And these header lines don't really fit. They're strings, they're kind of clunky, they come in every time the Arduino resets, so we just want to take them out. And then we're going to start a timer because we're actually going to do the timestamp in the Arduino IDE instead of doing it in MATLAB or Python or something like that. So we're going to be sending 3 data points at each loop. It's going to be time, temperature 1, and temperature 2. So we'll start the timer in the setup, and then we'll read the timer every time we take a piece of data in the main loop. And we actually have to define time when we call it in each loop. And here we'll print time as the first column, and we'll also print a comma separating it from the first temperature, whereas before we were just printing temperature 1 and temperature 2. Okay, so now that we've uploaded that to our board, we have to write MATLAB code to open a serial port, read the serial port, and plot the serial port, and optionally save the figure and the data after we're done with all that. So here's a new MATLAB script. All I've done is added a header and some clear commands just to clean up the workspace every time we run it. So the first thing we want to do is just reset all the USB ports and external hardware our computer's connected to. And we use an instrument reset command, inst reset, to do that. And now we're going to create a serial object. I'm calling it arty, just like the last video. And you just do that using the serial command. And you tell MATLAB what port you're using. I had to use tmtool again. Opens a UI window. And if I click serial, this shows me all the serial devices that are connected. I'm looking for something with a USB because that's what kind of port I'm plugged into, and I found it. They're such forgettable names. I don't understand why. But the important thing is that I have it. I'm putting it into MATLAB. Okay, so we're just going to gloss over the fact that I totally accidentally added a resistor array variable into MATLAB. We definitely don't need it because we're just taking the temperatures straight from Arduino. We actually don't need to convert voltage or readings to temperature. We already have it. So we're just setting a wait time. We want it to wait for 1 second. We're setting the number of loops to be 30. Take 30 seconds of data just like last time. And then we're going to set up the plot figure. And then optionally, you can set your axes limits. Sometimes this isn't the best thing to do, especially if you're taking data for the first time. I think it's helpful when you already have kind of a grasp of where your data is sitting, but you might lose some of the picture if you don't let the axes move with the data. Okay, so now we're going to set up the main read loop. We'll start with a for statement. We'll call I our index. We'll have it do 30 loops. And then we're going to take the time here just so we know how long every loop starts. We're going to call this loop begin. And then at the end of the loop, we'll take the time again and then wait for the rest of the second. So if the loop takes half a second, we'll wait for the rest of the second, another half second. If the loop takes 3/4 of a second, we'll wait for 1/4 of a second. Just so we're taking data on the second every second if that's important to us. If not, I would just say skip the step and do a simple pause command at the end. Now we're going to read the serial feed. So we'll call temp_array our variable where we'll store our data. And we're going to read all 3 columns of data using the fscanf command. So we want fscanf to scan the file called arty, our serial object. And we want to give it a format. So our data looks like time, comma, temp1, comma, temp2. So we should tell it, okay, so you're expecting a number with a decimal, a number with a decimal, number with a decimal. 3 floats separated by commas. And then we want to convert milliseconds, which is Arduino's default time, to seconds. And we could have done that in the Arduino IDE as well. That wouldn't have been difficult. But we didn't. We're doing it here. So we'll say the first value, in the first column of temp_array is that value divided by 1,000. That's our value in seconds. And now we actually want to live plot the data. So now we're just doing a quick plot command. I mean, honestly, once you have the data in the temp_array variable, you can do whatever you want with it. You can plot it, you can save it, never even look at it. It doesn't matter. The point is it acts like any other MATLAB variable. Here I'm going to plot it. I like live plotting just because I can see if something's gone haywire or if something might not be connected or if by some slim chance I've gotten everything right. Now we're going to add in this pause. So like I said before, at the beginning of the loop we took time. This is the end of the loop. We're going to take the time at the end, and then we're going to find the difference between those is the time it took for the loop to run. And then we're going to pause for whatever amount of time it takes to get the entire loop time to be 1 second. And after all 30 loops are over, we end the for loop, and we want to print our figure and save our figure. So we'll just do this at the end of the script. We want to save our data to a .mat file. And there we go, we're all done. Let's test it out. And going back to check my work, I missed a line fopen arty to open the file, and then comment out that 1 second below. All right, so let's run it. It's a second. Looks pretty good. Great. I hope this video was helpful, that it showed how to format the serial prints in Arduino to make them easy to read in MATLAB or Python or wherever they get sent, and then how to actually read those and live plot them in MATLAB. Thanks for watching.